Number 70. A city is located at 75 degrees north latitude. Assume the radius of the Earth is 3,960 miles and the Earth rotates once every 24 hours. Find the linear speed of a person who resides in this city. All right, so here's the Earth. Well, it's a little more circular than that, but although it's not a perfect circle. So let's say this is the Earth, okay? And they tell us, and let's say that this line first represents the equator, okay? What does it mean to then live, or what point on this Earth, right? And you're thinking about the surface of the Earth. Okay, what point represents 75 degrees north latitude? Now, since the Earth is really a sphere, all right, but I'm drawing a circle, it's a two-dimensional figure, that's why I'm saying point. But technically there's many points that might represent 75 degrees north latitude. So let's say that this point represents 75 degrees north latitude. Now, how does that even make any sense? Well, if I were to draw a line starting at the equator from the center of the Earth, meaning if I were to draw a, radius, okay, and I also drew another radius up to that particular point, what does this angle look like to you? What degree measure? Now, this isn't totally to scale, but hopefully that kind of looks like 75 degrees to you, roughly. All right, that means that at this particular point on Earth, that would be 75 degrees north latitude. Also, consequently, on the exact opposite side, that could have also been 75 degrees north latitude because it would have formed a 75 degree angle there. All right, but remember the Earth is a sphere, so there's many points. Okay, so what does it mean now if you live at 75 degrees north latitude to be rotating, with the Earth? So let me give a little perspective here. See if I can bring this in a little bit. I might have to shimmy this 1 second. Just bear with me. All right. So this will be close enough. So let me just dash this line in the back. Okay. So pretend you're this person, this little dot. As you rotate, or as the Earth rotates, you're only moving this particular distance, right? You're going to rotate around the Earth just like this. Okay. Every time the Earth rotates once, you're going to, let's say, start here and end up back in the same spot. And we're trying to figure out your linear speed, okay? That's what we're trying to do. So what we need to do in order to figure out your linear speed, okay, we need to figure out, remember, speed is simply going to always be some type of distance covered divided by some time over which that distance is being covered, right? You have a distance, how long, and the time is how long it takes you to cover that distance, all right? So, what's the time value? The easiest thing is, what's the time value in the problem? Well, they give us 24 hours, right? So that's probably going to be the time value, okay? The harder thing is to figure out what is the distance. Well, think about it. You're moving in this path. What would be the distance you traveled? Now, I don't want to know the number, but what would you need to know in order to figure that out? You would need to know the circumference. Right? What you're moving in is actually a circular path, right? You're moving in a circular path. So what you need to know is you need to know the circumference of this red path. Okay? So that's the distance. So what I'm going to do here now is say speed is equal to then the circumference of that red circle, all divided then by the time, okay, over which it took to cover that entire circumference. Now, how do you find the circumference? Well, you have to know the formula, right? Circumference is equal to 2 pi r, meaning 2 times pi times the radius of the circle. Whatever circle you're trying to find the circumference of, okay? And then that will be divided then still by the time, okay? I'm just going to label it t for now. Cool. So my goal now is to figure out what in the world is this radius. That's my goal, right? Because as this person rotates, this is the radius that's rotating. All right, round and round. Now that is not this radius, all right, in the problem, so don't plug that in. The radius they gave you is the radius of Earth. In other words, that is this radius right here, okay? But you don't want to know that radius, right? You might need to know that to figure out this radius, okay? But keep that in mind, that the radius they gave you in the problem, and I'm going to do it in black here. I'll outline that in black. Well, now it looks like one solid line. So let me just leave it in red. This radius right here is going to be 3,960 miles. Now this is also a radius too, isn't that right? This is also a radius because it's from the middle of the circle to the exterior part of the circle, right? So this is also a radius. So just keep that in mind, that we actually will know this length, okay? Now think about this for a second. If I want to find this radius, this length here, or this radius, would be the same thing as, if I just bring this straight down, it would be the same thing as this portion of the entire radius down here at the bottom, right? Okay, hopefully that kind of makes sense. So let me just bring that down again. So I want to find that particular length. Okay, what I'm going to start doing is I'm going to start creating maybe a little triangle. So watch what I'm going to do. I'm going to take this from this point where you are. I'm going to drop it down, drop down a perpendicular. Okay, in other words, it creates now a right angle. Now what I've done here is I've created basically a right triangle, if you noticed outlined there in blue-green. Okay. Now, if this is my triangle, oh, I had it perfect before, right? If this is my triangle, and I know the length of this side, which is known as the hypotenuse of that right triangle. Remember, what is that length? It's the same. This is a radius of the Earth, just like this was the radius of the Earth. So that's 3,960 miles, okay? So if I know this angle in the right triangle, I know the hypotenuse, and I want to find this particular side that is adjacent to the angle of interest, then I have to do a cosine calculation, right? So cosine of an angle is always going to be equal to the adjacent side divided by the hypotenuse, okay? Now all you're going to do, plug in for your angle, plug in the 75 degrees. For your hypotenuse now, plug in the value of the 3,960. And to find the adjacent side, all you have to do is a simple cross multiplication. All right, so let's plug that on into the calculator. Make sure, by the way, your calculator is in degree mode. If it's not, go to mode. And assuming you have a Texas Instruments TI-84 or any really TI product, and you want to make sure over here that you're in degree. Okay, if you're not, you just click down, click over, then hit enter. And that'll make sure you're in degree mode. All right, so let's clear out of that. Let's plug it in now. Cosine of 75 degrees, that's the whole point, is multiplied by now 3,960. And what do we get? So the adjacent side now is going to be 1,024.9. I'm just going to round it there, okay? Now remember, this adjacent side represented the length here, okay, in greenish blue, but that also represents the same length up here, which is indeed, right, because remember, that's what I did. I just brought it down and look, they match, right? So that, and now that represents the radius, okay? The important radius. This is the radius of the circle that you're making when you're moving, okay? So now 1024.9, that's the number we're now going to finally be able to plug in to my R there, okay? So let's just start plugging in the values. So now the speed is going to be equal to 2 pi multiplied by the radius, which is 1024.9. And the units there are miles, right? Everything is the length. I never did any conversions, and they gave me the length in miles, so it's going to stay in miles. Divided now by the time of 24 hours, because that's how long it takes you to go around the Earth once, okay, as it rotates. So now all you need to do is take out, again, that handy-dandy calculator and plug in the values. So watch what I'm going to do. 2 times now pi, okay, multiplied now by the exact answer. I want this exact answer. I don't want to use the rounded values. Just go up, just click up, it highlights it, hit enter, and it's going to plug it in for you right there. Beautiful, right? And then just divide it by the denominator value of 24. And this is now the answer. So 268. And you can do 0.3, you know, where should you stop it? I don't know. I guess technically, since they only gave you 2 sig figs here, it should be 270. But for some reason in math, they don't really care about the sig figs. And then when you get to physics, it's like, oh my goodness, you know, you gave me the wrong number of significant figures. Now you failed the test. You know, it's a little crazy out there. But, you know, such is the state of the world. Anyway, I'm just going to round it to that point. And all that we're going to plug in now are the units, and it was in miles per hour. So if you live at, 75 degrees north latitude, you're traveling at 268 miles an hour. Let me ask you, linear speed that is, not angular speed, but linear speed. Imagine now you're at the North Pole. Okay, you're standing exactly at the North Pole. What do you think your linear speed is now? Not rotational speed, but linear speed. Well, you're not really making any circumference anymore. So you'd be traveling at 0 linear speed, okay? Your minimum linear speed is at the North Pole. Your maximum linear speed is going to be at the equator. And everywhere in between these 2 points, it's going to be decreasing as you go along. Guys, thanks so very much for tuning in. I really do hope this helps. And if it does, give us a hand. Like, subscribe, tell some of your classmates. We appreciate it very much. I'll talk to you soon.